Namaste. Today in this video we are going to discuss about semantic nets and frames. Okay, so semantic nets and frames. Okay, semantic nets are the graph with nodes representing objects and arcs representing relationship between those objects. Okay, and there may be various type of relationship which may define using semantic nets. Okay, is or, that means inheritance, and has a, that is ownership, are two types of must use relationships. So let's consider an example. Okay, Toyota, this is the node. Okay, Toyota is a car. Yes. Okay, a car is a vehicle. Okay, so this is a relationship, and car has mirror, so it has a relationship. Semantic nets are computationally expensive at runtime, as well as it need to traverse the network to answer some question. In worst cases, it may need to traverse the entire network and then discover that the requested information does not exist. Okay, it cannot model human associated memory, as human brain consists of number of neurons, and it is about 10 power 10 neurons which are interlinked with each other. Semantic nets are logically inadequate as they don't have any equivalent quantifier. Okay, that means it does not use universal quantifier as well as existential quantifier. So let us consider an example of semantic nets. Okay, a person is a mammal. Okay, so it can be expressed as mammal. Okay, so person is a mammal. Okay, similarly, okay, bemol is a person. Okay, person is a, so bemol is a person. Similarly, person has nodes. So person has nodes. So bemol is in Nepali team. So it can be expressed as bemol team Nepal. Similarly, bemol, okay, uniform color is red or blue. So uniform color of bemol is red or blue. So these are the statement, and its semantic nets are these. That means node and relationship arc. By combining these 1, 2, 3, 4, 5. Okay, 5 statement, we can generate the graph as like, okay, mammal, person. So person is a mammal, and person has noses, okay, is a, bemol is a person, and bemol team was Nepal, and bemol uniform color, okay, is red or blue. So this is a semantic net of this 5 sentence which generates a graph. Yes, so if the graph is too large, semantic nets is computationally expensive at runtime. So we use frames instead of semantic nets in that case, if we have to use low cost computational machine. Okay, so now let us discuss about frames. So frames, okay, so frames are the data structure for reasoning stereotypical knowledge of same concept or object. That is, it is the collection of attributes and associated value that can be described some entity in real world. Frames are similar to schema in database management system. They are developed form of semantic nets and can be used to encode knowledge as well as it supports in reasoning. Frames consist of various components and they are termed as slot. Okay, so let us consider a simple example frame. So I am considering a simple example frame. Okay, it consists of frame name, okay, student. So the name of frame is student, and properties. It may be age, it may be GPA, it may be rank. Okay, so it is simply as a schema of a database. Similarly, frame, okay, frame name, okay, course. So its properties are CNAME, course name, credit hour, okay, course ID. So it is a simple schema, and we can establish a relationship as this register, so which helps in encoding of knowledge. Okay, but semantic net does not helps in encoding of a knowledge, and it is more complex to encode than that of the frames. But to understand graphically, semantic net is much more easier. Okay, but it has more computational cost. That means it is computationally expensive, but frame is not. Yes, so frame is used where we require lower cost of computation. So in this way we have discussed about the frames and semantic nets. Okay, and in next video we will be studying about learning or machine learning. Okay, thank you and bye bye.